All right, welcome back everybody. My name is Mr. Swaner, and today we're going to be talking about exponents raised to a power. Before we begin, make sure you pick up your companion notes so that you can follow along to this presentation. And let's go ahead and just start with a proof of what raising a power to a power actually means. So if we look here, I have x cubed to the fourth power. And what that literally means, just like if I had x to the fourth power, that means x times itself 4 times. Well, here I'm going to take x cubed times itself 4 times. So this literally means x cubed times x cubed times x cubed times x cubed. And I can use my multiplication rules to see that I would get x to the 12th. So let's look at another one here. I have x to the 5th power to the 3rd power. So that literally means I'm going to take x to the 5th times itself 3 times. And then if I use my multiplication rules, I see that I have 5 plus 5 plus 5. That will give me x to the 15th power. So our rule is that if I raise a power to a power, that all I have to do really is multiply the powers together. So if I have a number to the a power raised to the b power, I could just do a times b. So let's look at doing some of this mentally. If I have x to the 3rd to the 7th power, that means I'm going to do x to the 3rd 7 times. So really all I have to do is multiply that together. So I'll do x to the 3 times 7, which is 21. R to the 6th raised to the 5th power, that means I'm going to do r to the 6th power 5 times. Or I could just do 6 times 5, which is 30. Lastly, if I have a to the 10th raised to the 8th power, that means I'm doing a to the 10th power 8 times. So I could just multiply 10 times 8. That gives me a to the 80th power. Okay, so let's toss some coefficients in here. Now, we're going to start with the proof and what this literally means. So, just like what we were looking at before, this literally means 3x cubed times itself twice. So I'll have 3x cubed times 3x cubed. And then we're going to go ahead and combine our like terms. So I've got x cubed and x cubed, which will give me x to the 6th. And then I have 3 times 3, so that's 3 squared, or 9. So my final answer here is 9x to the 6th power. Okay, so let's look at another one just like that. So I have 2x to the 4th power, and I've got that raised to the 3rd power. So I'm going to do this 3 times. So I'm going to have 2x to the 4th times 2x to the 4th times 2x to the 4th. And then we're going to go ahead and collect our like terms. So if we look at our x's, that would be 4 plus 4 plus 4, should give me x to the 12th. And then I have 2 times itself 3 times, so that's 2 to the 3rd, or I could multiply that all out. 2 times 2 is 4, times 2 is 8. So our final answer here is 8x to the 12th power. Well, our rule is, if we want to kind of shortcut this, is we're going to give the power to all terms in parentheses, because I'm doing, in this example, 7x to the 4th. I'm doing that 5 times, so I'm going to have 7 to the 5th power, and then x to the 4th to the 5th power. I'm going to be doing each of those 5 times, and so we're just going to simplify this x to the 4th to the 5th, which will give me 7 to the 5th, x to the 20th. Make sure you understand this rule, because this will really help you out and make your life easy. So let's look at a couple using this rule and using this mental math. So I need to give this power of 4, this 4th power, to each term in there. So I'm going to give it to the 3 and to the x squared. So I should have 3 to the 4th and x squared to the 4th. And then the last thing I have to do is just simplify this x squared to the 4th. I can make that simpler. So I'll have 3 to the 4th and x to the 8th. Okay, so here we have 9x to the 8th to the 3rd power. So I'm going to give that power of 3 to each term. I'm going to give it to the 9 and to the x to the 8th. So I should have 9 to the 3rd, and then x to the 8th to the 3rd, and then the last thing I need to do is just simplify this x to the 8th to the 3rd, which will give me 9 to the 3rd, and x to the 8 times 3, which is 24. Okay, same thing here. If I have 12x to the 7th to the 7th power, I'm going to give that 7th power on the outside of the parentheses to each term. So I should have 12 to the 7th and x to the 7th to the 7th. So I'm going to give that power to each term. And 12 to the 7th, I'm going to leave that alone. And then x to the 7th to the 7th, I'm going to multiply 7 times 7. So I should get 12 to the 7th, x to the 49th. Okay, well, if we have multiple variables, we're going to do the exact same thing. We're going to give that exponent on the outside of the parentheses to each term inside. So let's go ahead and distribute this. So I should get b to the 3rd to the 5th power, and then x to the 4th to the 5th power. And then I'm going to use my power rules. So I'm going to do b to the 3 times 5, which is 15, and x to the 4 times 5, which is 20. Same thing here. We're going to give this power of 4 to both terms. So I have g to the 7th to the 4th and r squared to the 4th. And then I'm going to use my rules. G to the 7 times 4. 7 times 4 is 28. And r to the 2 times 4. 2 times 4 is 8. Okay, I can do the same thing if I toss a coefficient in there. Again, I'm just going to give this power to each term in there. So I'm going to give this squared to the 3, to the x to the 4th, and to the y cubed. So let's go ahead and do that. So I'm giving my squared to each term. So I'll have 3 squared, x to the 4th squared, y cubed squared. And then let's go ahead and fix our x and y's. So we'll have 3 squared, x to the 8th, and y to the 6th. Same thing here. We're going to give this power of 4 to each term inside the parentheses. So I'm going to have 4 to the 4th, x to the 6th to the 4th, y to the 9th to the 4th. And then we're going to go ahead and fix our x and y. So we're going to have 4 to the 4th, and then x to the 6 times 4 is 24, and then y to the 9 times 4 is 36. Okay, well, we can continue doing this and continue using our rules to work with these coefficients. Don't be afraid of this 5 squared. We're going to continue following those rules. So we're going to give the power of 3 to each term in here. So I'm going to take 5 squared to the 3rd, x to the 4th to the 3rd, y to the 8th to the 3rd. And now we're going to fix all of these. So I've got 5 to the 2 times 3, that's 5 to the 6. X to the 4 times 3, which is 12, and y to the 8 times 3, which is 24. So I'm just using these power rules and distributing my power throughout the terms in the parentheses. So let's look at another one here. I've got 8 to the 5th, c to the 9th, h to the 7th, and all of those we're going to raise to the power of 5. So I'm going to give that 5 to each one. So I'll have 8 to the 5th to the 5th, c to the 9th to the 5th, and h to the 7th to the 5th. And then we're going to use our power rules. So 8 to the 5 times 5 is 8 to the 25th. C to the 9 times 5 is c to the 45. And h to the 7 times 5 is h to the 35th. You can see these problems get a little bit bigger, but it's the same process, it's the same rules all throughout. Okay, so let's look at some negative exponents. So if I had x to the negative 2 raised to the 3rd power, I'm going to use this same rule that tells me I can just multiply these two exponents together. So I'll have x to the negative 2 times 3. Well, negative 2 times 3 is negative 6. But I can't leave my base and exponent like this. I cannot have a negative exponent. So if you remember back, our rule is if we have a negative exponent, we can just move that exponent from the numerator into the denominator position and turn it positive. And likewise, if it was negative in the denominator, we could move it up to the numerator position. And then here, this is just looking the other way. If I have the negative exponent on the outside of the parentheses, I'm going to do the same thing. I've got x to the 2 times negative 3. Well, 2 times negative 3 is still negative 6, and I'm just going to have to fix this just to make it look right. So let's look at a couple of examples like that. So if I have y cubed, and then I've got x to the negative 2 to the 4th, let's rewrite this. So I should have y cubed times x to the negative 8. Well, I can't have a negative exponent. What do I have to do? All I do is just move that x into the denominator position, and that exponent becomes positive. And I want you to notice here that I didn't take y to the 3rd to the 4th power because it's not included in those parentheses. So this 4th power only belongs to the x in this case. Okay, so now I have 2, and then in parentheses I have x to the 4th, y to the negative 5th, and both of those terms are going to be squared, but I'm not going to be giving this squared term to my that's outside of the parentheses. So let's go ahead and distribute that out. So I've got 2. Notice I didn't raise that to the 2nd power because it's not included in the parentheses. And then I did x to the 4th times 2, so 4 times 2 is 8. And then I did negative 5 times 2 to get my negative 10. And then the last thing that I need to do here is I see y to the negative 10. I cannot have that, so I need to move that into the denominator position. Okay, here's something just a little bit bigger. We're going to have to collect some terms together when we're done here, but let's go ahead and distribute this power to each term in the parentheses. So I've got a to the 4 times 3, which is 12, x to the 3 times 3, y to the 7 times 3, and x to the 2 times 3. So I just went ahead and did all my power rules right there. So I've got a to the 12th, x to the 9th, y to the 21st, and x to the 6th. Now there is one last thing that I can do here. I can combine my x terms. So I should get a to the 12th, y to the 21st, and then I'm going to combine x to the 9th and x to the 6th to become x to the 15th. Okay, here's another problem, very similar here. So I'm going to go ahead and distribute this power of a power to every term inside here. So I've got a to the negative 3 times 3 is negative 9, 4 times 3 is 12, 2 times 3 is 6, and negative 7 times 3 is negative 21. So now I've got a couple of negative exponents, so let's go ahead and fix those. Let's keep our b to the 12th and r to the 6th up top where they are, and they're okay, I don't need to move those. But I do need to move my b to the negative 21. I'm going to move it down to the bottom to make that positive. And then a to the negative 9, I'm also going to move to the bottom to make that positive. And then the last step here, I see that I have b's that can cancel out. I've got 12 on top and 21 on bottom, which will leave me r to the 6 up top, and I'll have 9 b's, or b to the 9th power down on the bottom, and a to the 9th stays there, nothing to cancel out with. So in closing, when you are raising exponents to a power, you need to distribute the power to all of the terms inside the parentheses, and then you will simplify. And that's really all there is to it. Well, thank you very much for joining me. Again, my name is Mr. Swaner, and until next time, study hard and keep practicing.